Hello, and welcome to today's webinar, What's the Latest and Greatest? GNSS Products for 2014 and Beyond, brought to you by GPS World and Platinum sponsor Hemisphere. I'm Bethany Chambers from North Coast Media, publisher of GPS World magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are currently in a listen-only mode. The recording will be available 2 weeks from today on our website at gpsworld.com/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways in which you can participate during today's presentation. Please notice in the lower left-hand corner of your console that there is a Submit button. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be covered in an upcoming issue of GPS World magazine or in one of our e-newsletters. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Rick Aldrich or I will personally assist you. Now I'd like to turn today's event over to our moderator, GPS World editor and publisher, Alan Cameron.
Thanks, Bethany, and hello, everyone. Welcome to another webinar sponsored by Hemisphere GPS, and we very much appreciate their annual sponsorship of this series, Continuing Education for the GNSS Community. We're here to talk about the latest and greatest in GNSS products. Now, you may well know that great products, new products appear pretty much constantly in the GNSS community, but they might be said to peak around this time of the year because of two conferences that are held in early fall. The Institute of Navigation GNSS Conference, which I recently attended in Nashville, Tennessee, and many of our speakers did as well. That's the U.S. show, the largest U.S. Exhibit of GNSS goods and products, and also the Intergeo conference and trade fair for geodesy, geoinformation, and land management, which is held every year in Germany. It's a gigantic affair. It specializes on one particular aspect of PNT, and that is largely to do with surveying, mapping, geodesy, and so forth. But it's conservatively perhaps 10 times as big as the Institute of Navigation show here in the U.S. So there's a lot of excitement around that show, and at least a couple of our speakers attended that show as well this year. So we're going to talk about some of the products that came out of these two shows that were lined up to roll out at these two shows, and others throughout the fall and winter. In the wireless sphere, for example. And we're also going to talk about some of the trends in the various sectors. And we're talking largely or very roughly about two sectors within the PNT realm today, the two most important ones, I would say. One is on the consumer/wireless/smartphone side, and we have Frank Van Diggelen from Broadcom to speak to that. This sector, if Frank, correct me if I'm wrong, but it is perhaps less demanding in terms of position accuracy than the high precision side, but it has very high requirements in terms of availability, particularly indoors, and in terms of power use and battery life. And I'm sure there are other factors as well. On the other side of the equation, or at the opposite end of the spectrum, we have the high precision sector, which we saw a lot of at Intergeo, and here used primarily in surveying, mapping, and a number of other related fields, construction, for example. And here accuracy is the driving factor, but not the only one. And we have Kirk Burnell and Ramsaran from Hemisphere to address that side, and also my contributing editor for surveying, Eric Gakstatter, will weigh in. Finally, we'll have time at the end of the webinar for your questions, and we encourage you to submit them through the question function on your webinar interface there. I'm going to talk very briefly about one product in the survey realm before I turn it over to Frank to address the consumer wireless smartphone sector. And this product is the new Triumph LS from ION-GNSS. You see a picture of it here. It's quite a machine. It incorporates GNSS, a GNSS antenna, and a very powerful receiver with UHF, GSM, Bluetooth communications, a host of other functions. This is the successor to the Triumph VS that was introduced about 3 or 4 years ago, and ION-GNSS has been working on upgrades and improving all the features in that model, which when it came out I likened to a receiver on steroids. This one I would say is kind of like a muscle car. It's almost got more than you could possibly use, although in Javad's way he's looking into the future and building today for the future. This receiver, or the chip inside this receiver, has 864 channels, truly a staggering amount. When you add up all the satellites flying in the sky today and the ones that we can expect to see over the next 5 or 10 years, you're somewhere in the 100 realm, maybe 150 at most, but somewhere between 60 and 120 most likely. Why would you need 864 channels? Well, talk to Javad for the full answer on this, but many of those satellites are broadcasting on multiple frequencies, and he has scenarios where a number of these channels are being used for other functions, particularly related to interference, which is a growing issue in the field. The Triumph LS has 3 processors, 14 megabytes of memory, digital filters, anti-jam filters. It is just packed with features, and like I say, it's almost more than one person can use. But again, Javad is building for the future. I wanted to give a quick look at that one before we pass now to the wireless sector, and I'd like to introduce my colleague Frank Van Diggelen, who is Senior Technical Director for GNSS and Chief Navigation Officer at Broadcom Corporation. Frank, take it away.
Thank you, Alan, and good day or good evening, depending on where you're from, where you're at. I'm Frank Van Diggelen from Broadcom. Broadcom makes wireless chips for consumer products, in particular cell phones, and in particular we make GNSS chips. According to the most recent analysis of this, ABI Research just published a document that said we shipped 173 million GNSS chips last year, so that gives you an idea of the scale. And it's all consumer, and so I'm going to be focusing on what consumer products were talked about and shown off at ION last month. So I've organized it into 3 categories. The GNSS products that were spoken about or presented in the various sessions. And in these slides, what I've done for you is shown you the relevant papers and which session they were in. So if you go online to ION and want to download papers, that's where you can find them. So that's why I've put that second column there. So I've got it organized 1/3, 1/3, 1/3. 1/3 was consumer GNSS spoken about in the technical sessions at the conference. 1/3 is indoor location that was spoken about. An interesting thing, you see about equal number of indoor location talks as consumer GNSS talks. And then there were products on the show floor related to consumer GNSS. Now, anyone who's been at ION knows that you don't see the consumer products on show at the floor so much as products that would be used by people making consumer products, so simulators and so on. And so that's what I'll be talking about. It's related to consumer products, not actually consumer products themselves. Okay, so I'll begin with consumer GNSS trends that were discussed and papers that were presented. And one of the biggest recent trends in consumer GNSS is the focus on ultra-low power, in particular to support something called geofencing. Now, you've probably heard of geofencing. I'll just review what it is. It's a feature of a GNSS product, like a phone, whereby it's continually checking your location in the background without you doing anything, so that when you cross some predefined boundary, which is what a geofence is, it's a defined boundary, virtual boundary, then something happens in the phone. It might give you an alert to say, remember to buy the milk because you were just getting near the supermarket on the way home, or it might tell somebody else where you are, or it might change the way the advertising gets brought up in the next Google search you do. So those kind of things are driving the need for always-on ultra-low power GNSS in consumer products, especially smartphones. And the strongest catalyst for this is Google, since they've released Android 4.3, which supports hardware geofencing. And so in any new Android phone, there is support for this. And what hardware geofencing means is that the GNSS chip can be operating independently of the host, and the host can be asleep. And the host AP is the thing that draws most of the power in your phone and runs your battery dead. So in order for geofencing to work, you have to have the support in the operating system, and you do have it now. And so that's led companies to focus on this, and the architecture that's resulted is chips that are host-based. So all GNSS chips in cell phones are host-based, which means when they're doing regular navigation, like turn-by-turn directions, they're using the application processor of the host to do most of the calculations. However, the new chips support something called host offload, so that although they are host-based, when the host is asleep, they can nonetheless manage to do some simple location functions, such as checking your position against a geofence. And so Broadcom was presenting one particular chip called the 47521, which supports this mode of operation and has this architecture. So the other big trend for consumer GNSS was the addition of new constellations. And so all the various players in consumer GNSS silicon were talking about products and or architectures that support GPS, GLONASS, BeiDou, and Galileo, and of course QZSS, which is GPS-like, so I've just lumped that in with GPS on this slide. So in particular, CSR was presenting a new product called the Surfstar 5 XP, which combines GPS and GLONASS with Iridium. And so Iridium is not traditionally a navigation satellite system. It's a low Earth orbit system, which is why I've shown you the Iridium satellite just to the right there, kind of at a different orbit, if you like, from the others. And Iridium is owned by Boeing, so this was a joint CSR-Boeing presentation. And the idea here is to have the communication that you get from Iridium combined with the location that you get from GPS or GNSS. And there also is some location function that can be done from Iridium itself, but somewhat limited. The main location there still being done by GNSS. Then ST Microelectronics also was showing off a chip talking about a chip called the Tessio 3, which supports GPS, Galileo, and GLONASS or BeiDou. And then finally, Broadcom presented a paper talking about preferred architecture for consumer GNSS and showing this block diagram down the bottom here that really the preferred architecture you want is to have a tri-band front end so that you can get GPS, Galileo, GLONASS, and BeiDou. So BDS there on my slide stands for BeiDou system. That's become the acronym used by China. and so everybody else for BeiDou. And so now to summarize this slide, you see a trend here that you either have chips that support GLONASS or BeiDou, or you have an architecture that supports GLONASS and BeiDou. And the difference is really in the RF front end. Do you have tri-band or do you have dual band? So a lot of the existing chips, such as the Surfstar 5 or Testio 3 that have come out, they only are dual band, so you have to make a choice. If you're going to have BeiDou, which adds 14 satellites, you have to give up GLONASS, which takes away 24. So there is a compelling reason then, if you're going to add BeiDou, to want to keep GLONASS. So that's the reason to have a tri-band RF chip. And so that was the summary of all those different presentations there. Okay, so now moving on to the second column of the three columns I began with, which is indoor location. So there was more and more of a focus on indoor location, which is appropriate on account of this was the ION-GNSS Plus conference for the first time. If you look at the history, we used to have ION-GPS, then we had ION-GNSS, now we've got ION-GNSS Plus, and one of the big pluses that we're adding to GNSS is indoor location, and one of the main technologies that is rising up as the dominant one for indoors is Wi-Fi. And there were two papers on Wi-Fi round-trip timing, one paper by Intel and one paper by Broadcom, and these both showed similar facts and similar development summarized by this slide. This slide is taken from the 802.11v standard. This is standard. 802.11 is the standards for Wi-Fi, as you probably know. And the 802.11v standard is to support timing synchronization between handsets and access points. And by making a small change to that standard, the IEEE can support time of flight measurement. So you can actually get ranging from Wi-Fi using time of flight in an analogous way to what we do with GNSS. Just to give you the background, before this is done, the state-of-the-art now in all your cell phones is that signal strength is used to estimate the range from an access point. So it's using signal strength to estimate the range, not nearly as accurate as actually measuring time of flight. And so this diagram shows the protocol for sending messages back and forth so that you can measure time of flight. I won't go into the details here. I just want to summarize what was said. Was both Broadcom and Intel showed some of the work that's being done in the standards committee and how round-trip timing to support time of flight is coming to Wi-Fi. And moving on for other kinds of indoor location. So this is also a time of flight method that I'm going to talk about, ranging from dedicated wireless towers, and NextNav is the company doing this. So this sounds a little bit like what I just talked about with Wi-Fi, and it's a little bit like doing location from cell towers, but what separates NextNav from anybody else is that they have licensed some spectrum in the cellular band. They actually own some spectrum in the US, and they're focusing on E911 indoors. So currently, when you put a location system of any kind into a phone, you have to pass E911 tests, and the test specification has to be met across a range of test points, some indoors, some outdoors. And so basically what happens now is when you're outdoors, your cell phone will get positioned to good accuracy, a few meters, and when you're indoors, it will get it to very bad accuracy, like more than 100 meters. And on aggregate, the E911 tests are passed. And so what NextNav is proposing is that there should be an indoor-only E911 spec, and in anticipation of that, they are putting up towers that transmit signals that you can range off of somewhat. So it's kind of like, well, it is, in fact, a pseudolight, if you think about it in a classic GNSS terminology, a pseudolight that would be compatible with cell phones to enhance the performance you'd get for indoor emergency location. And then another interesting indoor location technique that was presented was the use of magnetic anomalies. This was presented by someone from the University of China, and the idea here was to combine pedestrian dead reckoning based on MEM sensors with measured and remembered databases of magnetic anomalies, so what happens as you move around a building is that the magnetic field is changed by the metal in the building. And if you can survey that in advance, then that could help you know where you are. And so this chart on the right shows you microteslas in different coordinates as you move around the building. A microtesla is not a very small car. It's actually a measure of the magnetic field. And so this is the idea. This is interesting on account of it's got such a long history. In 1676, there was a book written called Longitude Found by a guy called Henry Bond, who thought who they just discovered that there was such a thing as magnetic north, and so there was magnetic variation across the globe. And so the very same idea was proposed for determining longitude. That didn't work. That was 1676. If this managed to work indoors, it would be truly historic, but faces a historical. There's a long list of people who've tried to use measured magnetic anomalies to determine location, and so it's interesting from a historic point of view. So now I'm going to move on to actual products that were shown on the show floor. As I mentioned, there are no consumer products per se, but there are products that are used in the development of consumer products. And the main ones for these are test and simulation. So two companies were showing off new products there. On the right, we have a Spirent data recorder and simulator. And on the left is the LabSat data recorder and simulator from Race Logic. Approximately to scale there, you can see the LabSat one is nice and small and has a cute little LCD screen, so you can see which satellites are being simulated. And then the interesting thing about this is, again, you see this question of whether the product is dual band or tri-band. So the Race Logic product, the LabSat product, the little blue one, can support either GLONASS or BeiDou, but not both at the same time. And the Spirent product is differentiated by the fact it can support both GLONASS and BeiDou, because those are on different bands, different frequency bands. Having used both of these products quite extensively in my job, I can definitely say they both really are in a beta stage. They've been released fairly fast, and the software that goes along with them is still, for all intents and purposes, beta. And then finally, this is my last slide. I just want to talk about some other cool products that were on the show floor and have some relation to consumer product development. The top two are both combinations of GNSS and INS systems, and the reason those are used in consumer GNSS is whenever people are testing consumer products, especially for driving tests in cars, they use a truth reference system, and the dominant truth reference system at the moment is the Novatel SPAN system, which has a ring laser gyro, IMU plus a Novatel receiver. And these two products from VectorNav and GeoINav are possible competitors to that. And then the last one on that slide shows a very interesting thing, which is a handheld jammer detector. So as there's more and more sources of GNSS jamming, particularly when you're in development, because people who develop GNSS tend to jam themselves because they have somebody with an open RF front end in a lab somewhere that's transmitting on L1 or something like that. It's kind of useful to have a product like this that could help you detect jamming. And so that's that last one. All these products on this slide were shown at the NAVTech booth, and so NAVTech is the distributor for these. And that concludes my presentation. Thank you.
Thank you, Frank. And before we turn to the high precision sector, I just want to mention that one of the trends that Frank talked about, specifically ultra low power host offload GNSS positioning, is the subject of the cover story in the next issue of GPS World. It'll be out in November on your desks and in your mailboxes during the first week. If you're impatient to see it, you can probably pull up the digital edition on November 1st on our website. or if you subscribe to it, it should be released then. I'm working on the story right now with a couple of Frank's colleagues on ultra-low power host offload GNSS positioning. Now we're going to turn to the other end of the spectrum, the other side of the coin, so to speak, high precision positioning in its many forms and manifestations. And for that we have Ron Ramsaran, Senior Product Marketing Manager for Marine Products at Hemisphere GNSS, and his colleague Kirk Burnell, Product Marketing Manager for OEM boards. Ron and Kirk, the floor is yours.
Thank you.
Great. Thanks, Alan. As we just saw a great presentation from Frank on the consumer and low power markets, we've prepared some material for today to show what we see as trends in the high precision market. So one thing on this slide you might notice is Hemisphere. First of all, we this time last year we were called Hemisphere GPS, and we were part of a larger company that focused also into the precision agriculture market. At the beginning of 2013, we were sold off as a separate company from the agriculture team. That company is now called Ag Junction, and we're called Hemisphere GNSS, and we've got a slightly different logo and everything. So it's the same company that you've seen before, just with a updated logo and updated name to reflect GNSS. That GPS is no longer the only game in town. So with that actually is a great point with the trends that we're seeing. We're seeing that no longer is it just about GPS. It's about GPS and GLONASS, and even more recently, discussion about Beidou, Galileo, QZSS, which is a Japanese sponsored navigation system, and the ION-GNSS, which is the India sponsored satellite system. So we're talking in high precision terms where people want to track all of these or all of the advantageous solutions available for them. The other thing we see is that people are no longer focused on position as the thing. That's 10 years ago, that's what you'd see as a position source is what you need in their application. Now people look to position and velocity, and now also orientation. I think maybe this comes a lot from the handheld phone market, where people use their apps and the integrated tilt sensors and digital compasses inside the cell phone aid the GPS solution or application, and as people turn around, they see themselves turning on the map. Their view, their virtual reality, whatever they're playing on their screen is moving with them. That is something that's new and sometimes blurs the line for consumers as to what GPS actually does. So that's coming more of a making more of a presence in the products and technologies we're seeing and the requests we're getting from the market. As well, we've gone away from the component system in a lot of cases. It used to be the classic GPS receiver, had a separate antenna, a special cable, and then you had data cables to a computer and power cables to a power source. 10 years ago, we moved into the all-in-one survey systems where batteries, radios, antennas, and receiver were all on top of the pole. And those are classically called the all-in-one solutions. We had the data collector then being the separate device down at eye level with or hand level for the surveyor to use. That's going in a different direction, and this is interesting. When we look at how China has played a role in GPS and GLONASS and GNSS, it's generally, it's a great place for manufacturing, quantities of high quality electronic fabrication. That's always been a source for that. It hasn't been a leader in the GNSS market. The Chinese market started the handheld with all the sensors built in. And we saw that on the manufacturing side, that everybody in China looking for manufacturing wanted to put the GPS or GNSS receiver inside the handheld and have the data collector and everything via smart data collector, whereas the rest of the world, Europe, North America, South America, Africa, were looking more for the traditional all-in-one, on the top of the pole solutions. So there's been a momentum shift in who's directing the requirements for the next generation of survey and high-precision GIS and mapping products. And this dovetails right into the last point here. Originally the breakthrough was having portable GPS, and that often meant batteries that weighed less than a few kilos or 5 pounds, that sort of thing, and going into a mobile application. And what we wanted to look at there is now those mobile applications are putting the data collection software right in the user's hand. And now the data moves from there to the cloud. So I'm just going to go into here a little bit about BeiDou satellites, because it's a new system and it's a little bit of a departure from what we've seen with GLONASS, GPS, and Galileo. In the lower left corner, we have something that says BeiDou for MEO satellites. MEO satellites are mid-Earth orbit, and those are much like GPS and GLONASS and Galileo satellites. They orbit the Earth, once or twice a day, and they have a sine wave pattern they leave over top of the planet. Then on the larger picture on the left, we have 5 GEO satellites. That stands for geostationary. Those satellites stay parked over top of those points along the equator, and therefore they're visible all the time to a certain region of the Earth. What's different about BeiDou is they also include the inclined GEOs. Those are parked out right next to those geosatellites, but they wander up and down as the Earth turns, and they create this figure 8 pattern. And those satellites then provide better coverage when you get to the further north or further south latitudes. And also thrown on that one slide is a red loop. That's for the QZSS satellites, the Japanese satellites, has a similar inclined orbit. It's a little bit different in its shape. But you can see all of these satellites pass very well over top of Australia, and they're visible literally from New Zealand, through Australia, through Africa, up through Europe, and across Russia, India, and Southeast Asia. There's a very, very wide footprint. And that's what we get when we talk to people about BeiDou. They're like, oh, that's a Chinese regional system. Well, it's regional if you consider the entire Eastern Hemisphere the region, and over 2/3 of the Earth's population live in the Eastern Hemisphere. So BeiDou it benefits more people on the planet than it doesn't. So that's something to keep in mind. So as they mentioned earlier, there was a show in Germany. So we prepared some slides a few weeks ago for what does BeiDou do for Europe, because it's certainly not part of what we consider China. When we talk about China, you don't think about Europe as part of the region. So these numbers on the slide are showing the average number of BeiDou satellites you see during the day over top of different regions in Europe. So that's above 15 degrees. This isn't just above the horizon. This is a usable satellite signals. And as you get to southern and eastern Europe, you can see you're getting 3, 4, almost 5 satellites a day in some regions. So that's a significant number of additional measurements to be making. So when you look at that in terms of what's the benefit, if you say, okay, I already have a GPS GLONASS receiver, what does 3 or 4 or 5 satellites mean? We're looking in the 20 to 30% to 35% improvement in Eastern and Southern Europe. France, Spain, England, they're getting a little bit further around the planet and not seeing as many of those geos, and there's still measurable improvement. And again, this is above 15 degrees, so that's fully suitable for RTK measurements. So people say, well, I've been using RTK GPS for a long time, and I don't see why I need to move to all these new signals. So just wanted to do a little bit of showing here. When we do the satellite predictions for this, we noticed that there's a number of times during the day that there was 5 or 4 GPS satellites above 15 degrees. That's all. So totaled up in a 24-hour period, how much of the day we spent with 4 or 5 GPS satellites above 15 degrees. That means RTK is not possible, or if it is, it's very slow to respond during this time. And you can see through Central and Southern Europe, you're looking towards 2 hours a day where you're not going to be able to do RTK with just GPS alone. And if you look just off the coast of England in the upper left corner there, that's the worst on the map here. It's 150 minutes a day. That's 2.5 hours a day of 4 or 5 satellites for GPS. You can't run a business and expect your crews to be out working when potentially a quarter of their workday is going to be spent with poor satellite coverage. Reminds us it's a military system. If we look down to the southern Mediterranean, we all of a sudden see as we get towards the Middle East region that we're getting into 30 minutes a day, and I think some of them were less than 30 minutes a day where there's outages. So it's still being managed for the U.S. military use. So one of the products we introduced is a high-performance multi-GNSS, multi-frequency engine. That's our Eclipse P306, P307. It's got doesn't have the 800 channels that the Javad system is boasting, but it does have a ton of channels for tracking, 372 channels for tracking satellites. It can track up to 89 multi-frequency satellites at one time. It's Galileo and QZSS ready, so as those systems come online and become more of a improvement to solutions, it's just a firmware upgrade to bring these new systems onto this board. So it's got 34 or 20-pin configurations for different models that are available. That same engine is integrated into our new GeoMapper 300. This is a all-in the handheld survey data collector. It's got the 300 plus 372 channel receiver built in. It's got a laser rangefinder, digital compass, digital barometer. It's got 2 cameras like your smartphones do. That's not idealized for doing live chats with your friends. It's idealized for taking photographic evidence of monuments or survey conditions or through the rangefinder, so you can have a look at your target information, that sort of thing. Connectivity, it's everything you expect in a super high-end digital device these days. It's got modems for a cellular network, Wi-Fi, and Bluetooth. It has a hard LEMO port to handle a direct serial connection if you have devices that need that. Also storage to a small card, micro SD storage cards. Its bigger brother, the GeoMapper 500, is a large screen tablet. You can use it the same way for surveying, but typically people looking for the large screen are the GIS users. They'll be able to put as much on the screen as they can and map and check for all the different feature codes and things. It's got your digital compass and barometer again and multi-cameras and a number of the wireless connection techniques. Last point on this slide, Android OS. Microsoft has been supporting the mobile market through an outdated CE platform for a number of years, and the feature list was not growing since sort of the early 2000s. Android, there's been a significant push to have Android OS on platforms, especially ruggedized platforms, and the GeoMapper 500 brings that to the market. So I'm going to switch now to Ron, and Ron's going to focus on the marine precision market and applications.
Thank you, Kirk. Just to expand on what Frank and Kirk has delivered about GNSS plus IMU initial systems, how do we use these products into real-life applications? And I'm going to discuss a bit on the global navigation satellite system has really revolutionized the marine operations by providing the fastest and most accurate methods of vehicle navigation, vehicle safety, and efficiencies. And other marine applications where accuracy of heading, positioning, pitch and roll, rate of turn, heave, speed, and course over ground. Some of the high-end applications, and just to list a few marine applications where GNSS plays an important role in the safety of life at sea, particularly in the automatic identification system, autopilots, hydrographic surveying, dynamic positioning, and remote operated vehicles, which is fairly new, and it's a really nice concept that's actually taken the market. Safety of life at sea. One of the vessel traffic and other waterway hazards make maneuvering very difficult, and the risk of accidents become greater. Hemisphere GNSS compass in an AIS application uses a transponder system that operates within the VHF band and is capable of communicating ship to ship as well as ship to shore. The ship's position and heading is embedded in the transmission. All essential information on the vessel's movements are uploaded automatically to the electronic charts. And that really assists in the prevention of vessel accidents. For autopilots, what is shown here is that for the autopilots, we notice that flux gate and gyro compasses are being eliminated, and mostly GNSS compasses have taken over, which provides heading, position, and rate of turn. For instance, the product in the top right-hand corner gives you roughly 0.5 degree heading accuracy. It's very quick. It gives you accurate position to 1 meter, SBAS corrected, 95% of the time. And you have the advantage of providing pitch, roll, and somewhat heave. Moving to the next slide on hydrographic surveying. GNSS compasses are especially useful for hydrographic surveying coastal waterways where a few land-based reference points are known. Some GNSS compasses, such as the Hemisphere, can provide accurate pitch roll and to compensate for the ship's motion. Another application which has taken hit, especially in the oil and gas industry, is dynamic positioning. Works in applications providing the use of accurate heading, pitch, roll, and position of vessels in reference to platform stability. On the next slide, on the remote operated vehicles, we noticed that in rivers, lakes, where bigger vessels cannot get in to do hydrographic surveying, there's the use of these remote vessels coupled with multi sonars and also coupled with GNSS receivers that could provide position, heading, pitch, roll, again, and some heave calculations. So on the product lines, I've shown 3 different products, Pulse MV, which is a GNSS product tightly coupled with an IMU system. And similarly, Novatel spans, it's the same GNSS system coupled with an IMU that gives you the ability and flexibility to get to the different accuracies required for the different applications, for instance, dynamic positioning. On the other side, it's the Vector 3 VS330, which is a Hemisphere product, which gives you the flexibility of using GNSS products. When it's capable of doing dual frequency GPS along with GLONASS, and in the future, as Kirk discussed with our new GPS engine, Beidou engine, we'd soon be able to provide Beidou for regions where we can get full coverage, and makes it more unique and able of less multipath blockage coverage, gives you better satellite distribution and geometry. My final slide would show other systems and other products that are in the marine world that really is coming on stream because of MEMS and cheaper IMU systems, and also to give you the ability to be able to navigate remote automatic vehicles underwater, particularly the IMU systems provided by SBG Systems, which has an MEMS-based IMU system in there with dual frequency GPS engine. And then you have some of the less accurate ones like XSense and Epson that provides accuracies of pitch, roll, and heading that are less accurate to 1 degree out of accuracy. And then we have the Hemisphere product, which is an all-in-one inclusive GNSS antenna, where the antennas, it's a dual antenna system, which actually provides a heading accuracy of 0.7 of a degree. And so there, within the marine market, as you can see, there are different products and product lines that are coming. GNSS products are more favorable. They're used in a tightly coupled or loosely coupled system of INS to be able to calibrate, or vice versa. The IMU systems would be able to help the GPS find its position a lot quicker. And with that in mind, thank you.
All right. Thank you, Ron. We're going to turn to Eric Gakstatter now. Eric attended both the ION-GNSS conference and the Intergeo conference with me. Eric, give us your views on the latest and greatest.
Sure. Thanks, Alan. I don't have any slides there, so there's nothing wrong with your screen if you don't see one. But I'm just going to discuss a few things, both on the ION-GNSS show and Intergeo conference. Just sort of at the 50,000-foot level, certainly, one of the primary emphasis at ION-GNSS was to talk about MEMS and research with MEMS and inertial navigation, which kind of dovetails into indoor positioning, like what Frank was talking about. Me not being a pure electrical engineer, I can't tell you the challenges, although I'm sure I am, of getting those types of devices to fit inside a mobile phone or to fit inside a handheld for GIS or mapping or surveying or just general navigation indoors. But, you got to feel, at least from my perspective, that eventually this technology is going to make its way into phones and other mobile devices that will enable us to accurately navigate indoors, and I guess accurately is a subjective term, but certainly much better than today. And I just saw at the conference, I saw a lot of papers given on this type of technology, and just certainly you see the trend. And that's a great part about going to ION is you really see what people are working on and things that will be actual products in, the 2 to 3 to 4 year window. So certainly, again, a big push on inertial nav and MEMS, sort of GPS or GNSS augmentation type of systems that will allow people to navigate in places where they can't navigate today. And then one of the other issues was discussed a bit was interference and jamming, and Frank mentioned that new product, which I thought was kind of neat too, that I think they call it a handheld interference detector or the jamming detector. I really see a great need for these at some point if they're at a good price point. And just my experience personally was last year I was on a 600 or 800 foot ship, and I was watching the captain navigate the Columbia River up here in Portland, and the receivers were knocked out for a period of time, all the receivers on this ship, and it really made me wonder, what the source of that was, and how neat would that have been to have some sort of handheld interference detector or jamming detector to see if it was something on the ship that was causing it, or what the source was, because we really didn't know. But then again, on the flip side, you hear a lot about jamming and interference of receivers, but you listen to the Department of Homeland Security, and you really don't hear, or they really don't tell you, or I guess a better way to put it is they haven't seen a significant uptick in the reports of jamming or interference. We hear always about the one back in, was it 2007 in San Diego Harbor when there was a big jamming event down there, and you hear about the incident at the Newark airport where the guy was driving by the airport with a cigarette lighter jammer. But I don't, as much talk as there is about interference and jamming, and I'd invite comment from folks here, is there's a lot of talk about it, but is there really that many actual events that are disrupting the use of GNSS? That's not to mean that there couldn't be, but it just seems like I don't hear a lot about increased events that are really disrupting people's lives. And maybe we can hold the comments at the end, but I'd be interested in hearing the discussion from the folks here. So just a couple other notes about ION. There was a presentation about the NDGPS system, the National DGPS system, which is operated by the Coast Guard and the U.S. Department of Transportation and the Army Corps of Engineers. There was a report from the DOT that there is no federal requirements for NDGPS now from at least the Department of Transportation and the Coast Guard. I think they're all moving towards WAAS for navigation. And so the status of NDGPS is up in the air, and what they're doing now, the DOT is doing now, is they're going to evaluate the cost of decommissioning the system and then make a decision next summer about what the future of that's going to be. Now, I am told that the Corps of Engineers is going to maintain their reference stations, which I think numbers in 7, 8, or 9, somewhere around there, but the vast majority are DOT and Coast Guard, and so the future of those are really in question right now. There'll be another piece of news. There'll be another 2F satellite launch next week, October 23rd. That'll be the second one of the year, and of course we all hope that the GPS Directorate and Congress get into giddy up mode so we can launch more satellites and benefit from more capabilities. So that'll be number 2 this year, and I think, if I'm not mistaken, they were going to launch 2 next year. And then the last piece of news that I noted from the ION conference was, what the folks mentioned before in this webinar was the Chinese BDS satellites. Of course, I travel around a lot, but I never really use RTK in any other area except North America, somewhat in Europe. But I've been told how valuable BDS has become over in the eastern region for RTK, because it offers so many more satellites on top of what's available already. And so, just another note on that is, when I talk to folks about, especially in North America, they don't understand the influence that the Chinese market has on high precision receivers. I think generally speaking, those who try to estimate what the market size of the worldwide market for dual frequency receivers is, it's around 100,000 or 110,000 a year or something like that. The majority of those are consumed by the Chinese market alone, and the rest of us are the other 40% or so. So it just tells you how big that market is and how useful this technology is over there. And so that sort of dovetails into the next conference I went to, which is over in Europe last week at Intergeo. And like Alan said, this is a huge event. It's the biggest one in the world, focused on geospatial type of applications, software and hardware. There's 16,000 people, I think, somewhere around there. And there's just nothing that rivals it in North America at all, or any other place in the world. So it's a great place to catch up on GNSS technology, as well as software and UAVs and LiDAR and all kinds of different mobile devices, all kinds of things. So there's three things that I really have brought out of that show that really struck me. The first was, and again, just dovetailing on RTK, is the number of different RTK receivers out there is just mind-boggling. I mean, it just seems like it exponentially grows every year when I go to that conference. It's interesting because here in North America, you have three big players, Topcon, Trimble, and Leica, that sort of dominate that space. And you go over to this conference in Europe and you see how many RTK receivers from different vendors are over there. And it's just mind-boggling. I didn't count, but there had to be probably 15 different vendors over there selling RTK receivers of all different shapes and sizes. And so I think what's going to happen is you're going to see increased competition. You're going to see reduction in price of the receivers. Of course, lots of them are just Me Too type of receivers. Well, a manufacturer will see something in the market and they'll decide to design something similar to it and just sell it at a cheaper price and hope that will gain their market share. But just all kinds of different receivers over there. And so, again, I think what it'll lead to is more competition in the marketplace and more choices for the user community, which is a good thing. So the second thing that I noticed over there, and this is sort of an ongoing subject, is that of UAVs, or unmanned aerial vehicles. Here in North America, we're sort of shielded from that because it's still not legal to fly these commercially. You have to have FAA approval, and then typically it's limited to government agencies or universities for research. That said, President Obama has mandated that by 2015, the Federal Aviation Administration introduce rules for commercial use of UAVs, and so that's only a couple of years away. But over in Europe, there's some constraints certainly, but not as many, and so there's lots of UAVs being flown for commercial applications, and I think within Africa and Australia also, maybe South America. I'm not sure about that. But there's a huge number of UAVs, both fixed wing and rotary UAVs, all different kinds of price ranges. Even some manned vehicles, very small ultralight type of vehicles. So it's I think when finally the FAA comes around in 2015 to publishing the rules of commercial use in North America, or in the U.S. at least, you'll be able to hit the ground running with lots of different choices of products out there, because there's so much R&D being spent on developing mapping type of UAVs. Again, all the way from just $1,000 or $2,000 all the way up to $60,000, a whole range of them, and lots of clients that I work with in my consulting business are really taking a hard look at UAVs, and there's certainly it's a game-changing technology in the mapping and GIS space. And then lastly, tons of mobile devices, all different kinds of shapes and sizes of mobile devices at the Intergeo show. We heard earlier from Kirk and Ron about supporting Windows and supporting Android, and we're even seeing some iOS stuff, but lots of different devices at this conference, from ruggedized handhelds, which, if you look back 5 or 6 years ago, there was only a couple, 3 players that offered ruggedized handhelds. Now they're being, they're commonplace, and they're getting a lot less expensive than they were before, because there's many more vendors supplying them. Tablets are the same way. I mean, I saw many different 7-inch and 10-inch tablets, ruggedized, semi-ruggedized, just a huge variety of these kinds of devices that are all used by geospatial professionals, mostly driven by manufacturing out of China. And it really resonates what Kirk and Ron said, is that they see this market, and Chinese manufacturers want to mass produce these sorts of things, and sometimes that does a good thing, and sometimes they don't fit that well. But certainly what it does do for sure is it opens up competition and pushes each designer to do a better job and make more efficient products and products that are more useful for geospatial professionals. So those are the big three subjects. Maybe we're getting close to being out of time, Alan. I'll pass it back to you, and maybe we can do some Q&A, or I'll leave that to you.
Okay. Thanks, Eric. We are at the top of the hour, but we're going to take a few more minutes to field a couple of questions from the audience. So if you'll stay tuned, we'll go for about another 10 minutes. The first question, or actually first two questions, they kind of come from similar angles, and they come at the convergence of the two fields, the two sectors that we've been talking about, the consumer on the one hand and the high-precision survey-oriented on the other hand. The two questions, I'll just read them both and then ask Frank to talk about the first one, and then Kirk or Ron to talk about the second one. Here we go. What technology is available for high-accuracy positioning with smartphone or tablet devices? And then somebody else wanted to know, sort of correspondingly, what is the role for a qualified GPS surveyor versus one who can operate a smartphone for data capture? We see these two sectors converging. Frank, what can you tell us about the potential for high accuracy with devices in your end of the market?
Okay, well, it's a great question because often people assume that a small chip such as goes in a cell phone must be inferior, but it means they haven't been paying attention to Moore's law. Moore's law says the size of the transistors gets twice as small every 2 years. They don't get worse. They actually get better because as they get smaller, you use less power, so the chip doesn't heat up so much. So the 2-millimeter chip inside the cell phone actually has the capability that when GPS started, if you had a chip that had that capability, it would have been 260,000 times bigger. So of course there was no such chip that big. So in other words, the chips that are in cell phones today have more capability than anything possibly imagined when GPS was first started. And in particular to this question, they do measure carrier phase. A lot of people don't know this because you can't really get at it as a consumer. And iOS, iPhone operating system, you can't even find out which satellites are being tracked and what the SNR is. In Android, it's a bit more open. You can see which satellites are being tracked, what the SNR is, but you can't get at the raw measurements. However, manufacturers can get at the raw measurements, of course. But then the problem is the processing software. In terms of getting sub-foot on single frequency, you'd need some kind of post-processing. All cell phone products are L1 only, by the way. With GPS, GLONASS, Galileo, and Beidou, there's 3 different frequency bands because Beidou, GLONASS, and GPS are slightly different bands, but all within the L1 band. So it's really a single frequency product, and that's the case for all cell phone GPS. But in that single frequency band, they can measure carrier phase very accurately. And the post-processing products out there, such as Gypsy from Unavco and other similar ones, only support dual frequency. So if someone listening and wants to go make sure that these would support single frequency and do something like float RTK solutions, then you very possibly could get sub-foot accuracy out of a phone. So as I mentioned, now you can't just do it with off-the-shelf phone, but if somebody's got the post-processing software, then get in touch with me. Maybe I can get you some measurements, and you could do something really cool. So by the way, you can always get me through LinkedIn or through GPS World or something like that.
Yeah, Alan, I'd like to add to that. This is Eric, and I don't know if Frank was being modest or not, but actually Frank used to work for Ashtec, which of course were manufactured and designed high-end receivers back in the 90s and into the 2000s up until now. So Frank has a lot of experience with RTK.
All right. Kirk and Ron, do you want to address the second half of this question? What's the role for a qualified surveyor, GPS surveyor, versus someone who can operate a smartphone for data capture? Do you find any of your customers worried about this?
Sure. It's Kirk here. This is a great question, and I mean, you read the survey blogs, and this is always coming up. So I guess this is the thing: it's as we march towards more accurate measurements, we're going to get exactly that, more accurate measurements. Interpreting those measurements, making sure that we're using two-dimensional flat Earth math when we need to, and moving to spherical math when we need to, and then elliptical math when that's relevant. Those are the keys that will distinguish, a surveyor doing something professionally or somebody doing something quick and dirty and easy with a much lower cost technology or widely available technology like Frank was just talking about. So, we see this already when you have people mixing OmniStar VBS data with WAS data in North America. They're on different datums. If the untrained operator or user just assumes they're the same thing, they'll have a couple meter offset, and they think they've got half meter accuracy, but they've built in problems like that. RTK is that times 10. When it comes to that, you are referenced to your station, and if you start mixing different, let's say, mobile phone carriers, potentially might have different solutions this way, you could be in for a large mess if you don't do it professionally. So it might provide a great tool for the backyard surveyor, but to go do something professionally, I think you're still going to need all the legal qualifications that come with surveying. So.
Yeah, I'd like to just add to Kirk's comment too. It's I think from a professional surveyor's point of view, things like data quality, it's a big thing. It's nice that the average Joe or the end user can do GPS, but there's needs for people to still understand things about multipath. Why is my data not lining up? Why am I not getting my data points to plot in the right location? I think there's still need for professional surveyors to address that. And I mean, in our industry, we still do see people trying to stretch the limits of GPS or GNSS by putting antennas under obstructed areas and expecting it to fully perform or function in that aspect to hit the requirements that the product is spec'd to. So, thanks, Alan.
All right, thanks. We're going to run this last one pretty quick here, and it bounces off a statement that Eric made about the 2F satellite about to be launched. The next GPS 2F satellite was originally scheduled to go up today. Well, a couple of weeks ago it was postponed into next week to October 23rd, and then just yesterday it was announced it's going to be postponed further for unspecified reasons. We haven't posted this to our website yet, so Eric can be forgiven for not knowing it. I just found out about it this morning. At any rate, it feeds into the next question. Do you think that the slippage of the GPS modernization and the possible reduction of the GPS constellation will affect the release of new products that use GPS? We're going to give each of our speakers about 30 seconds to address this. Frank?
Thank you. Not at all in the consumer world. The new constellations such as GLONASS, Galileo, Beidou, that's driving development. Any new smartphone now is already GPS, GLONASS, and QZSS compatible. So there is no such thing as GPS only in smartphones anymore, at least for the new smartphones. And Beidou is the hot constellation this year, and that's driving development. And Galileo in next year or the year after that, ION-GNSS. So it's the new constellation that are driving development.
All right, thanks. Kirk or Ron, you want to address that at all?
Sure. I echo what Frank's saying. In the high-end market, we're already doing very precise measurements currently with GPS, GLONASS, Galileo, Beidou. So that's going to continue. Some of the new features that come with modernized GPS would bring things like better tracking under treed environments, these sort of things. With 25 satellites visible at a time, you can do some pretty good things under trees as it is. So it will delay it, but it's not going to taint the punch.
Eric, final words?
Yeah, boy, I hate to give the GPS directorate a pass, so I don't want them to slow things down, but they're right in that GPS isn't the driving force; it's the other constellations. We still need the new capabilities that are offered by GPS, and each satellite makes a difference. And so I don't want to give them an excuse to slow down, but certainly I don't think it'll slow things down, if at all, with new product development, because these other constellations are moving pretty fast right now.
All right. Well, thank you, gentlemen. That winds up our webinar for today. Bethany will have a couple of words for you in a minute about the next November webinar, which covers a topic that was raised here, at least in passing. I want to thank our sponsor, Hemisphere GPS, for, once again, the 11th in this series of 12 2013 webinars. We'll have a great lineup for you again next year, and we've still got, this is the 10th, and we've got 2 more this year. This is Alan Cameron from GPS World saying thank you to everyone for attending, and back to you, Bethany.
Thank you, Alan. An on-demand recording will be emailed to everyone in the audience 2 weeks from today. You may also check back and receive that from our website, gpsworld.com/webinars. As Alan mentioned, please join us for our next event, Unmanned Aircraft Navigation, which is scheduled for Thursday, November 21st at 1 p.m. Eastern, 10 a.m. Pacific Time. The event will be moderated by GPS World's Tony Murfin and will feature guest speakers from Accord Technology, Novotel, Micropilot, and Rockwell Collins. You can register online today also at gpsworld.com/webinars. And for a preview of the topic, you can read today's issue of Professional OEM Newsletter for a column by our webinar moderator, Mr. Murfin. The article is also available at gpsworld.com at the top of our homepage right now. Thank you again for attending today's event, and this concludes today's webinar.